part 2. We are not always given a graph and asked to determine the slope from a graph. Sometimes all we're given on paper are 2 points, not a graph at all. Although you could grab some graph paper and plot the 2 points that you're given on a line or on a coordinate plane and count the squares between them, just like we did in the calculating slope part 1 video, the first video. If that's how you feel comfortable doing it, I have no problem with that at all. If you are a person who likes formulas and can use formulas, then this is the video for you. I myself am that kind of person, but I can do things both ways. What we have over here on the right hand side is a formula right here, is a formula that can help us find the slope of any line as long as we're given 2 points. For whatever reason in algebra, the letter M is used to stand for slope. Why, I can tell you why they would not use a letter S is because oftentimes people's S's can look like 5s, so they wouldn't want it to be confused for a 5. Why M was chosen, I do not know. But this formula, and whenever you're given a formula in math, it tells you exactly what you have to do to be able to come up with a value for a given item that's missing. And in this case, this formula tells us that the rule is to take the y value from one point and subtract the y value from another point in the numerator on the top, which would actually be your rise. The y-axis is the axis that goes up and down on the coordinate plane. So when you're calculating rise, you're finding how a graph changes along the y-axis. So that's the rise. Along the bottom, the formula says to take the x value from one point and subtract the x value from the other point. And the reason you're subtracting the x's on the bottom is because that corresponds with the run. Remember when you're calculating on a graph, it's rise over run. And when you run to the right or the left, you're actually running along the x-axis. So you're finding how the x-axis changes along your graph. So now, even though it says that you want to take these little 2's and 1's, they mean y sub 2 minus y sub 1. So that basically just means the y value from one of your points minus the y value from the other point. It does not matter which one of these you call x1 and x2 and which one you call y1 and y2. So let's just say I happen to call this x1 and y1. Remember, in an ordered pair, the x value always goes first. You don't have to write this every time. I just wanted to write it so that you could see what numbers I was plugging into my formula and why I was putting them where I was. So if I want to find the slope of the line that would connect these 2 points, I need to subtract the y values and the x values. So over here, y2 is a 7. So I'm going to do 7 minus y1, and y1 is a 6. Now on the bottom, to find the change in the x's, it says to take x2, which is negative 1, and minus x1, which is a 3. Now I just need to do that math. 7 minus 6 is a 1. If I'm at negative 1 and I subtract 3 more, that means I'm going farther back, and I'll be at negative 4. So the slope of this line is negative 1/4. Not a very steep line, but a line that's going down from left to right. Okay, I would do the same thing over here. Now this time I'm not going to put the little x, well, I will this time. And the next time I will not. Okay, so we'll call this x1 again, and y1. We'll call this one x2, and this one y2. You'll see as we go down here, it's not going to matter, really, as long as you put all the y's on the top and the x's on the bottom. So we're starting with y2, which is a 7, minus y1, which is a negative 2. And then for the denominator, the x's, we're going to start with our negative 2 because that's x2 minus x1, which is a 3. Now I know up here you might notice I've got 2 minus signs together. The first minus sign comes from the subtraction sign in the formula. The second minus sign comes from the negative sign in front of the y value of that ordered pair. So if you remember when you were learning how to add positive and negative numbers, or maybe maybe this is a Miss Wagner thing, but you might remember keep it, change it, change it. And maybe here I'm going to do this a little bit differently. Oops, let's go back one more. So you might remember keep it, change it, change it. I changed the color so that you could see that that wasn't the original problem, in case you go back and look at this later on and want to watch the video again. So it wasn't originally adding a positive, it was originally subtracting a negative, but because I don't have any subtraction rules for positives and negatives, I had to change it to an addition, and that way I can add a positive number. So 7 plus 2 now gives me 9 on the top. You can also do keep it, change it on the bottom. Keep this -2, change it to addition, and make the 3 negative. I did not do that over here, even though I could have. Keep it, change it, change it. So, oops. See, math teachers make mistakes too. And it's even more difficult for me having to deal with this pen. So back to here, keep it, change it, change it. Okay. So then when I do my math on the bottom of this problem, -2 plus -3 is a -5. So my slope is -9/5. I can't simplify that. I can't reduce it. You could change it to an improper fraction. It is equal to -1 4/5. But most of the time, it's easier for us to work with our slopes if we leave it, I'm sorry, we could change it to a mixed number, but it's actually easier if we leave it as an improper fraction. If we were to go to graph this and use the slope as a rise over a run, it would be easier if it were just as an individual fraction and not with a whole number part. So it's beneficial to us to leave it this way. When you enter answers into Moodle, on the other hand, you're going to have to change it to a decimal many times. So you could take 9 divided by -5 and find out that that's equal to -1.8, and probably have to enter your answer in like that on Moodle. Okay, so then the next one, I am going to not put the x1 and the x2 down here, and just do the math below it. It does not matter which point you mark as x2 and y2. I'm going to put the -4 first. Oops, I'm using a different blue. And that's the y value from the second point, minus from the, whoops. This minus sign I'm putting in comes from the formula. And I'm going to minus -3 because that's the y value from the first point. Then I'm going to use the x value from the second point. Minus, because there's a minus sign in the formula, I'm going to minus 7 because that's the x value from the very first point. Now there might be some keep it, change it's here. I'm going to keep the -4, change to addition, and change the sign on the last number. I'm going to keep the 0, change to addition, but change the sign on that second number as well. And now I'll come over here and do my math. -4 plus 3, that will be a -1, and 0 plus -7 is a -7. So my slope would be a positive 1/7. A negative number divided by a negative number is going to be positive. And again, if you're putting this into Moodle, you'd probably go to your calculator and do 1 divided by 7, find out what that is as a decimal. Which is an irrational number. The decimal keeps going, although there is a pattern that repeats. But you would want to put in at least 3 decimal points when you're entering it in Moodle, unless the directions tell you otherwise. And this last problem. Okay, so in this last problem, I'm going to use the 8. I gotta find my, oh, there we are. I'm going to use the 8 first, minus the 4. I chose to use the 8 first because it's larger than the negative 4. Sorry, I didn't see the negative sign, so I'll make sure I put that in. Again, I could have put negative 4 minus 8, and this would work out the same. If I have space over here, maybe I'll do it the other way as well to show you that you get the same answer no matter which way. And then 9 minus 3. And we'll change to red. Keep it, change it, change it. Keep the 9, change to addition, and make the 3 negative. So then 8 plus 4 now gives me 12, and 9 plus negative 3 gives me a 6. So the slope of this line is 2, or 2 over 1 if you prefer. Had I done it the other way, putting the negative 4 first, negative 4 minus 8, and 3 minus 9, I want you to see that you will get the same solution. So if I go up here, change to red, and do keep it, change it, change it, keep it, change it, change it, you will see that you'll get negative 12 divided by a negative 6, which still does equal a positive 2. So you get the same slope either way.